Right, so it looks like we've got everybody in here. Okay guys, thank you for coming along. My name's Andrew Poole, I'm from Home Theatre Engineering. We work closely with Scott here at West Coast Hi-Fi Midland. I've got about 30 minutes to try and perform a minor miracle, which is to talk about video calibration, audio calibration, and a little bit about acoustic panels. Now, if you think that your audio and video system is perfect, leave now, because I'm going to upset you, all right? So I'm going to reveal and lay bare some of the facts about sound and picture. All right, so ignorance is bliss, and one of the great things is you unbox a product, you put it up and you go, wow, that's terrific, and what you don't know is what you're missing. But why is that important? Well, first of all, you've paid for a product and you deserve to get every inch of performance that you can out of that product. Why would you not? If you bought a car, you expect it to be able to do all the things that the car should do. The problem is, much like a car, the equipment that we buy has to be fit for the environment. So if you buy a Ferrari for the racetrack and try taking it four-wheel driving, you're not going to get very far. When we buy this equipment, when we put it in an environment, we change it. And make no mistake, the room is absolute boss. I don't care what cables you buy, none of them will change the sound as much as the room. Okay, so the same goes with picture. Once you fire the signal from your projector onto the screen, it depends on what kind of screen you've got, what ambient light you've got, and so many other factors in the room. So if you want to see the picture as the way it should be, and if you want to see the picture the way the creator intended, and if you want to get the most out of the product that you paid good money for, then by rights, calibration is what you need to do. The thing is, it shouldn't be called calibration, it should be just called getting what you paid for, right? Getting the performance out of your equipment that you paid for on day one. Right, and we calibrate car engines every day as they come off the factory floor. It's just that we don't know the environment that the projector and the sound system's going into. So what I'm going to do is I'm going to kick off with video calibration first and talk about a few things here and go through the basics. And I want to demonstrate a couple of things here. I'm just going to put up, does anyone know what the brightness control is for? Okay, no. Next attempt. All right, so who's stolen the remote control for the projector? Here it is. No? The Sony guys. Here we go. All right, so very quickly, I'm just going to go down to, oh, no. Okay, so we're going to use user because I've put some, right. So brightness. Someone said you use brightness to make the picture brighter. Can you see the pattern on the screen? Nope. No. Do you want to turn the light off? Brightness? Brightness is for black levels, guys. Right, now, it's very, very red and it's horrible, but if I adjust the brightness now, you'll start to see bars appearing on the screen. All right, so I'll adjust that so that's about correct. Now, forget the red, just ignore that. Right, that brightness level there is about correct. Now turn the light back on. You've lost all of that information on the screen. That's how important ambient light is, right? If your projector is not set up properly, you're not seeing anything. So all of your black details get washed out. All of those details down the dark alleys, all of that fine information, the background's completely lost, unless your black level's set correctly. Okay, so that's the first step, really. So let's have a look at another one. This is contrast. So I'll just go up to contrast. What does contrast set? White levels. Okay, so brightness does black levels. It's totally counterintuitive. Contrast does white levels. So as I increase the white level on here, you'll see that band in the center getting wider, and now it's clipping. All right, so that band, you can see no more graduation in here. So the projector's clipping, and if it was set up like that, we'd lose all of the detail in the sky. We'd lose everything. All you'd see is a white skyline, no detail, no clouds, no nothing, right? And you know, if there was a sunrise or a sunset, we'd lose it. So we adjust the contrast level until it's not clipping and until you've got full graduation across your screen. Okay, so these are some of the basics. You can do this at home, but you need to know whether you're going to do it with the lights on or the lights off, right? Because your ambient light affects the picture. All right, so let's go on to a couple of other things. Let's talk about color, temperature, and grayscale. These are all the things that a calibrator goes through when he attacks your video. All right, so these are stepped grayscale from black to white. okay, and they should all be grey. Now I've screwed with these, so that one's a bit red and that one's a bit green, and it's all completely wrong. And what I'll do is, hopefully if everything's still working, all right, I'll just pop this up here. We'll just do a very quick adjustment to get this right. But the interesting thing is, what is every level of grey made up of?
Black.
Red, green and blue. Okay, so black is no red, green and blue. White is all red, green and blue. And so the way we transfer from black to white and through the greys, these are all balanced red, green and blue. So what I'm going to do, let's see if this is actually going to work for me. Okay, can we turn the lights off for a sec? Okay, so we can see on here that, I don't know if you can see the computer, but you can see 3 red lines in here. There's 3 lines, a red line, a green line and a blue line. Now they're all supposed to be together and they're all over the place. This one on the left represents the grey level down at 30%, which is, so it's quite dark, and this is higher, this is at 80%. So what I'm going to do very quickly, we'll go into colour temperature, we'll go into settings here. If you write notes fast enough, you can calibrate your own unit. All right, so I'm going to keep this thing running, right, and I'm going to adjust the high level there. So I've got too much green, so I'm going to take the green down very quickly. I've only got a few minutes to do this, so it'll be the world's fastest sort of calibration. Right, adjust the red level. Red's far too high, but I need to bring down. Now, it's not as easy as it seems, because in fact, when you change one, you trade off against the other. So, yeah, I'm doing this as quickly as I can. Now, the other thing is that screwing it up is my lower levels are wrong, so they're actually affecting the higher levels, so I'm going to bring them closer to a neutral setting. Right, see how the grey is getting better? Right, that was a horrible red before, and this is starting to look like a far more natural white. So, bring my green down. All right, I won't go on for this for too long because it can get really boring. I know these guys at the front love watching it, but
it's rewarding, that's the point.
Yeah, but why is this important? Okay, this is really important because this is your canvas, right? When you make an oil painting, you start off with your canvas and then you lay your colours on top. Now you see how my high end, now all the colours are together and balanced. So I know that I've got the colour temperature perfect there, and then all I have to do is work on the lower end. Well, quick change over here. Right. Okay, so this is a lower grey. I've got way too much red. Green's got to come down a bit, blue's got to come up a bit. Okay. Green. Oh, I was adjusting the wrong one, damn it. Get it right in a minute, just gone dyslexic. Okay, so too much red, a bit more blue. Okay, it's very rough. Then I go back to my high one and so on until I get it right. Okay, but as you can see, we're starting to get closer now to a balanced grayscale. Now, if we go back to that pattern that I had before, here we go. If we're going to find the right one. Right, here we go. Oh, okay, don't. Okay. Don't give me a hard time. Go back to my colour bars. How's that looking? So before, these were all green, they were all red. Now we've got a nice even 6500 Kelvin grey. All of these are 6500 Kelvin. That confuses people a little bit, but that's the grayscale. I won't dwell on it, I just want you to see sort of what goes on. This is the foundation of getting your picture right in your projector. So we've got the canvas correct, now we need to get the rest of it right. So going from there, we then have to work on how the projector moves through, and how I find my control, how it moves from black to white. And that's called gamma. So we'll just go and have a look at that as well. Oh, of course, this is a Sony, isn't it? Gamma correction on. Okay, in an ideal room, in a dark room like this with no light coming through the door, the gamma would be 2.4. Right, but in a bright room, it would be 2. See the difference? What's happening? We're getting a little more snap and pop, right? But it depends on how much ambient is. So my job as a calibrator is to work out how much ambient light there is, where you watch the projector. Do you watch it during the day? Do you watch it at night? Do you have a light controlled room? These are all the questions we ask. So 2.2 is kind of an industry standard in a general sort of mildly lit room, and 2.4, and you could possibly push it to 2.6 if you wanted to in a pitch black room. 2.4 is the standard. Why is this important? Because when you're watching those movies and you're looking down, I keep referring to this, but those dark alleyways made of old black stone with moisture on them, and you know, those sort of dark gloomy scenes, if you get this right, you get every drop of detail down this alleyway and it looks incredibly three-dimensional. If you get this wrong, it's just a black patch on your screen. Okay, so you're missing all that information, and those poor cameramen and producers and actors struggle for days to get it right, and you're not getting it. Okay, so you want to get that performance out of your projector. Then finally, so that's the gamma, that's the way it steps. They've made that more complicated with HDR. I really won't touch on that now, but yeah, it's sort of got kind of interesting. And then finally, there is color management. I'll just shoot through the screens here. Right, I'll let this run. Hopefully, yep. So what we're measuring here is your color space. This is 1080 Rec 709. It's the old Blu-ray color space, okay? And this is what we've been watching for a very long time. We've now left that color space for you know, your new enhanced color spaces. So we've got what they call DCI and P3, and one day we'll all get to BT 2020, which is sort of the limit of what we're going to see for a while anyway, with projectors replicating what we can see with the human eye. So I've just run a quick scan on this projector, and it's pretty bad. Now, it's pretty bad because I've screwed with it, all right? So my blue should be there and it's way up here. My green should be here, it's way up here, and so on and so forth. So the color space is screwed up. Why is that important? Well, I'll show you. I'll put that through another test whilst I'm talking. Post-calibration, saturation sweeps, we'll skip that. Okay, this is the color checker. This is the most torturous thing we can do with a projector. So what I'm doing here is matching whether or not the colours from this projector actually match what we know in real life. This is looking at skin tones, Ferrari and Coke can reds, all the psychologically familiar colours that we work with, right? Now, the problem being is if I just do the primaries, if I do red, green, blue, cyan, magenta, yellow, that's fine, I get the outer limits. But if all of the interpretation of the colours in the middle is wrong, then unfortunately, it all goes to hell in a handbasket. All right, so just because you've got your primaries on the outside right doesn't mean that you've actually got everything okay. Now, if you look at that, what you're seeing in these bars that are popping up, right, these are the errors. The higher the bar, the greater the error. It should all be under that first line. An error of greater than 3 is noticeable. An error under 3 is not noticeable by the human eye. I aim for an error of 1 to 2. Right, in all of my work. So all of those ones that are picking up, they are going to be horrible colours. Your skin tones are going to be off, your reds are going to be off, your greens, and so on and so forth. So that's pretty much the nuts and bolts of calibration at Rec 709, Blu-ray standard. Then we flip over to HDR, that's the enhanced colour space, and we start to get into high dynamic range. That means that your grayscale gets a whole lot bigger. The amount of light output potential is much greater. To give you an idea, the specifications for HDR are 0.0005 nits up to 10,000 nits. All right, now there is probably, I think there's one TV in the world that can actually do that. It's a special studio monitor. But most TVs now are scrambling sort of over the 1000s up maybe towards the 2000s. Projectors, about 150. All right, so that doesn't mean you can't get great HDR with a projector though. If it's well calibrated and it's got plenty of light output, you can do that. But HDR is problematic and it does need to be addressed carefully to get really, really great results. Okay, so you can see there, see all those browns and pinks towards the ends there, your skin tones, completely screwed up. So if I spent some time on this projector, we will perfect that, and what that means is you'll see a great picture. Now, other than getting what you paid for out of the picture, why is that important? It's important because we as human beings are very familiar with certain things, and we know when something's right or wrong. It's like when you look at I mean, it's getting better all the time, but you look at something that has been created as an animation, and then you go, well, hang on, Why do I know that's not an anime? Why do I know it's not real? So our brain works really hard when we look at an image to relate it to real life. The less accurate the picture is, the more exhausted we get watching a movie or a TV show. So one of the reasons to also calibrate, apart from getting the money that you paid for or the performance you paid for out of your equipment, is to actually be able to sit and relax and really involve yourself in it and not suffer that exit door effect where you suddenly get a scene where the grass is glowing green and the faces are nuclear red and so on and so forth, because then your brain just goes, well, that's not right. And we just don't accept it anymore. Okay, so if someone can flick the lights on for a sec. All right, so a couple of sort of interesting questions about this. First of all, there are calibrators. There's not a lot of us around. We're a rare breed. There's about sort of 5 or 10 of us sort of full-time in Australia. Someone got my phone correct for the first time. But there are some catches. First of all, you've got to keep up with the technology, and all of your sensors have to be calibrated. I have to send mine back to the US every year. It costs me a fortune, and you have to pay the licenses for the software and all sorts of things. It's an expensive thing to do. And to have the right sensors to measure, especially HDR, is also expensive. So if you do get your system calibrated, you need to make sure that your calibrator knows what he's doing, ISF qualified, been working full time, knows his stuff. Make sure he's got good sensors, make sure they've been calibrated recently, that they've gone back to America, because that's where the standards are, unfortunately, and that everything's up to date. Because if this isn't right, it's kind of pointless, isn't it? All right, so you're wasting your time and your money, all right? Finally, it goes on from there. I've touched on HDR. HDR is a complex beast, but there are solutions that have been released. Cowman, who make this software, now have a new a BT20, heavens, for 2093, 2039. Anyway, it's a gamma that then takes the metadata from the signal that's coming into the projector, and then it works out the black level of the projector, the white level of the projector, and accurately scales it. And that works really, really well now. So we can get really stunning HDR results. How do you know if you're getting great HDR? Because it looks like you're looking through a window. It should look unbelievable. It should look like your screen's made of glass and you're looking through to the scene. And when you get that right, then you've got HDR right. So that's kind of one of the ways to know. Moving on from there, this is a manual calibration system. There are things called Lumigen Radiance Pro. There are scalers that you can buy. They're not cheap, but they do several things. And one of the things they do, and some of the TVs that are now available, and I think we might start to see it one day on projectors, use what they call a Lut calibration. LUT, it stands for lookup table. And what that means is, instead of me doing this and manually trying to fit everything in the box, it actually takes the color space and fires a whole heap, thousands of readings, and then measures them and actually adjusts them in real time until they're all correct. That's what studios do, but it hasn't been available to us for a while. And now, if you buy a Lumigen Radiance Pro or you buy a TV with LUT capability in it, then your calibrator can come in. I have to interface with the system. I have to set the whole thing up and it will go off. And if I do a high level LUT, it will do this for 12 hours. Right, but the picture quality you get will be unbelievable. So that's what's coming. The final thing is, you may remember anamorphic lenses. For those of you who know, so this is an anamorphic screen, it's not 16:9. When projectors first came out, there was a big call for anamorphic lenses because it was kind of the right way to get a picture on a screen. As zoom projectors came out, that changed a bit and anamorphic lenses sort of disappeared again. HDR's back, or here. And the problem with that is that when you zoom out for an HDR movie, have a shot at how many pixels you lose off your screen. How many do you think you lose? You lose more pixels in zooming to an anamorphic screen than is an original Blu-ray. So you take your entire Blu-ray image, throw it in the bin, and that's what's left. And if you think you're watching 4K, you're not. Right? You're watching 60% of your 66% of your pixels, right? And the other 30% are sitting in those black bars, top and bottom, that have been taken off the screen, and all the light that's shining into your chip is being bounced back into your projector. So if you really want to go the distance with HDR and all of its capabilities, and 4K especially, probably HDR is not quite the right term to use, 4K, if you want to optimize that resolution and pack it onto a screen and have every pixel in your projector being used, you've got two choices. One is something like a Barco with a full cinemascope anamorphic chip. The other option is an anamorphic lens. Neither are cheap, okay? And which is why zooming became in. All right? So there you go. That is the world's fastest description of basic calibration. I'm going to launch into audio calibration now. Are there any questions? All right, you're still here. That's pretty amazing. All right, so I'm going to change hats. I'm now an audio calibrator, and we'll fire off with that. Okay, much like video, who here thinks that the audio in a room's perfect? All right, how do we know what we're missing?
We don't, you can't hear it until you get it.
Okay, now to me that's a bit like, as we grew up, you got involved in coffee and wine and cars and other things, and as you go through your experiences in life, you discover that there's better and better and better. Sometimes you make a mistake and go back to what you knew, but we evolve, right? And unless we know what we're missing out on, it doesn't bother us. But with hi-fi, what gets me, and one of the things that gripes me, one of the things that drives me with my passion in the business is the fact that people spend an awful lot of money, and then miss out so much. And I'm going to show you exactly how much we miss out on. If I can get this right. TV audio. Now, I'm going to make a horrendous noise. Now, these, well, they were bodies, but I took the shapes out and turned them into X's. These are here for a reason. I'm going to generate a tone in this room. I want you to get up. Yeah, you've got to get up. And I want you to walk around the room. And the reason I put these crosses here, because I already know that these are spots that you are going to hear a difference in the sound. And one of them, there's two that really interest me. One is here. And this room could be the other way around, of course. And the other one is here, right here. If you stand here, and you lean forward slightly, just about here, right? You can look down on his head. You'll be amazed at what you do and don't hear in this room. And this is just one frequency. This is one frequency, right? And if your room's not set up properly, you are missing lots and lots of these frequencies in different areas, which is why your music sometimes feels a bit, yeah. Okay, because if you have room nodes, and you have problems in your room with your sound at varying frequencies, and I'll explain the reasons for it shortly, then you'll understand. So I'm going to make a horrible noise, and you can all walk around and just move from dot to dot and see what you experience, hopefully. Okay, move around the room. And then go to the back of the chair.
There's another one here as well.
Yep.
Yeah, everywhere, right? There's a beauty there.
Awful.
Yeah.
Oh God, I can't stand there.
440 resonance.
188 hertz.
188.
Yeah. Okay, that's one frequency in a room, just one. It's actually 188 hertz, out of interest. Could you all hear the difference as you walked around? Okay, I believe I've saved more marriages than anybody else, because if you're sitting there and it's dead quiet like it was back there, and you're sitting here and you're getting this amazing bass, right? You're going, would you just turn it down? And you're going, turn it up. Right? Oh, that was a bit close to the bone. So, my point being is, the problem is people don't know why. You're going deaf, or, the fact of the matter is the sound in the room is wrong. Right? So how do we fix this? There are several ways. Now, this is only bass management, and I'm going to have to blitz through this as well. But it comes down to the positioning of the subwoofer, right? Positioning of the seats. And then ultimately, at the end of all that, it is room treatment comes in a little bit, but in bass frequencies, that's a tricky one. And then it comes down to equalization. Auto EQ is what you apply after you've got everything else right. Auto EQ cannot move speakers and it cannot move seats. Right, so all it will do is stress itself out, have a nervous breakdown, and do the best it can.
And then create an awful EQ pattern.
Well, it will do what it can, but the thing is, it will only do what it can for the areas that you measured as well. So my job as a calibrator is to do that for all seats, which comes to a reason why you do 5.1 over stereo, but we'll get into that another time. So can you use acoustic treatment for bass? You can, but it's very awkward. You've probably seen those foam traps that you put in the corners. Okay, they would have to be so big and they would intrude into your room so far to do anything of value that they're sort of a waste of time. There are ways to manage bass in a room if you have some peaks by using what they call membrane absorbers or a thing called a Helmholtz resonator, but it has to be tuned to the frequency that's problematic, and if you don't know what that is, how do you do that? And then you've got to find someone who can build it and put it in the room. And even Cricks, interesting enough, modelled up some Helmholtz resonators, put them in the room, and because the room is different from a computer model, they didn't work. All right. So the answer for us as mere mortals really lies in placing the subwoofers in the right place and trying to save your marriage, sitting in the right place, and then once you've got all that right, then applying some equalisation to smooth it out. There's a great product called a mini DSP, I swear by it, it's just fantastic. It gives me control over all the subwoofers. The other thing is, guys, and this isn't a sales pitch, this is just physical fact, multiple subwoofers. Put 4 subwoofers in your room and we can control the bass over multiple seats. It's got nothing to do with power, right? It's got to do with handling those room modes. So I know, for example, there's a real peak here, right? And there's a real null there. Now, I can't practically put a subwoofer there, but what I can do is I can actually work out the coordinates of it and I can create a third subwoofer for free. If I put 2 subwoofers in the right place, that creates a third virtual subwoofer right in the middle of the room. Well, not in the middle of the room, at the confluence of those 2. So you can make subwoofers for nothing, which is kind of cool if you know how. All right, so that's bass, but what do we do about the rest of the sound in the room? The classics, the things I see are, speakers in cabinets, speakers, in corners, right? Why is this a problem? Someone want to tell me?
Yeah, we put it in move that speaker 3 feet out, it'll change back to what it should be.
Yep.
Put it in the corner, you've got about twice as much bass.
Yep, and there's another thing too, it's called speaker boundary interference response. So you're talking about boundary gain. So as you load it into the corner, we pick up massively in our bass response and it's disproportionate. The other thing that happens is, even though high frequency sound beam out of a speaker, the sound still emanates like you've dropped a pebble in a pool. So it expands out like this, it hits this wall, it bounces back into the room, and it joins the direct sound coming out of here, and it creates constructive and destructive waves. It's called comb filtering. So by the time it gets to our ears, it's rubbish. That's problem number 1. Problem number 2 is boundary gain, where anything you shove in a corner massively increases the bass, which is why subwoofers traditionally get thrown into corners, because it's money for nothing. You get 3 to 6 or more dB gain by putting a subwoofer in the corner. All right, the next problem is this: no speaker's perfect. Floyd Toole, who's a fantastic guru, turned around and said there's more information on the sidewall of a tyre than there is on a speaker. If you buy a speaker, I bet you the frequency response is something like 20 to 20,000 hertz plus or minus 3 dB. You know, there might be a variation. It might go up to 48,000 kilohertz, right? It's like, what? So what they don't tell you is this. It's called off-axis response. So this sound might be well and good. Hopefully it is. And by the way, price is not always a dictator of quality. All right? Scott knows his stuff, so generally his products are pretty damn good. Out of here you get your direct sound. As we get off-axis, the sound quality changes. Right? So what if that sound quality comes out of here, hits the wall and bounces back into the room? Now we start to fill the room up with all of these reflections. Right? Are they good reflections? No, they're bad reflections. And so what we do is we put acoustic treatment in. But is it the right acoustic treatment? If you go on YouTube, you'll see 1,000 guys telling you how to do acoustic treatment. They'll have foam panels they're gluing up all over the place. Right? Foam panels are notch filters. They take out a certain frequency, right? And they leave the rest to bounce around the room. Curtains are the same, carpet's the same. If you just throw acoustic treatment up and you walk in and you go, boy, that sounds different. Right? They're right, it sounds different because you've probably notched out something perhaps in the area of your voice or maybe a little bit higher, perhaps somewhere between 1,000 and 5,000 hertz, and it's different. Of course it's different. Is it good different or bad different? How do you know? Right. So the thing is, you need to measure what's going on in your room. 9 times out of 10, if you put the foam panels up everywhere, first of all, you've probably put them in the wrong place. They're probably the wrong kind of panels, and the improvement that you created is probably wrong. The other thing is, acoustic panels, you can put them on the wall, you put too many of them up, and you kill the dead space. So I'll go on to the next thing, which is reverberation time. One of the things that people talk about in rooms is you've got to kill the echo, right? Now, RT60 is an industry standard, or it's recognised as an industry standard. It's the amount of time it takes for sound to decay a level of 60 decibels. In a room like this, to make it ideal, you're looking at about 350 milliseconds. Okay? Most homes are pretty close to that. All right? So if you've got people, furniture, chairs, bits and pieces, bits and bobs, curtains, stuff like that lying around, you probably actually don't have a massive problem with reverberation. Now, in some rooms I've been in, you do. You absolutely do. You've got tiles, you've got glass and chrome, and and they're shocking, right? So yes, you need to treat that. But I've also been in rooms where there's so much acoustic treatment that the room just collapses in on itself. You lose your soundstage, you lose your envelopment. All right. So the trick is roughly 20% of your surface area with absorption, and you're probably going to be in the ballpark. So we don't have to worry too much about reverberation time as a kind of rule of thumb, but we do need to manage the off-axis sound, the quality of the sound that's being reflected to the sides, to the floor, and to the ceiling. Right. We then make sure that our subwoofers are aligned and that all the settings are correct. Now, how do I know that audio calibration is needed? Here's the saddest fact that I've ever come across in my industry. I've been doing this for years. I've not been to a room yet that's correct. And I'm not talking about small correct, I'm talking big correct. From issues where people have bought speakers from the manufacturers and they actually weren't connected internally, through to speakers that have been wired from front to back, out of phase, none of the settings in the amplifier set up, broken tweeters or drivers, or again, out of the factory. In one in every so many jobs I go to, actually out of the box we find speakers faulty or out of phase. You'd be really surprised. So we find a lot of problems in rooms. The great thing is that audio calibration puts more smiles on people's faces than anything else I do, unless I'm giving away free alcohol. All right, so that's an important thing. I'll just try and see what I've missed on here. I'll have a quick look. There's so many things and you've got to do it so quickly. All right. Okay, description of sound. You've often read reviews where people say, oh, it's silky or it's chocolatey or it's smooth. Well, what does that tell me about the sound system? Nothing at all. I'm an HAA calibrator, and Jerry LeMay, who runs the HAA, really drums into you what we call critical listening. So we use we use 5 terms: clarity, oh heavens, mental blank. Clarity, focus, envelopment, response, and dynamics. And we listen to soundtracks and we define each of those. So now, when I'm looking for something, I can turn around to Enzo, for example, who's my associate, by the way, meet Enzo. And I can say, there's clarity lacking in this room. And Enzo goes, I know what the problem is. The speaker's muffled, there's a plant in front of it or something like that. Or focus, the sound, that we need to know where the singer's standing exactly within the soundstage. Or envelopment, we're actually involved in the music. Or response, is the music, is the decay time correct? So if you hit a kick drum, does it linger around the room for half an hour? Does it just disappear? And dynamics, can we get the really quiet sounds? And can we get the really loud sounds? Right? So now, just by learning to listen to the right things and attaching them to the correct words, instead of me saying, if I said to Enzo, that room's really chocolatey, it's like, well, I'll go and have some of that to eat. It sounds great, right? But we need terms that work, right? So as an industry, we need to be able to work with that. So when I work with my customers, I try and teach them that. So they can ring up and say, Andrew, I've lost all my envelopment. And I'll go, okay, check one of your speakers hasn't stopped working for starters. Right, so and so on and so forth. All right. Look, basically that's the audio calibration part. I think the only other thing I want to say is, if you are going to use acoustic panels, have a look at what they're made of, and just understand this: if they are made of a lightweight fabric like a foam, all right, or they have a hard surface on the top, the hard surfaces are likely to be reflective. If it's foam and it's only a couple of inches deep, it's not likely to be working very, very well, or in a very limited frequency range. Okay, so you need to know what you need your acoustic treatment to do and what kind of acoustic treatment you want. This is the advertising part of the night. We spend a long time trying to find products that we could afford, that worked and looked good. We couldn't, so we built our own. So these are our acoustic panels, now made in WA out of all West Australian product, which we're kind of proud of. It is a high density fibrous material, weighs 98 kilograms per cubic metre. We started off with fiberglass, but we've improved that. It's in a reinforced frame. Then there's an air gap at the back. That's really important because we needed to extend the frequency range of this, so it's a broadband acoustic treatment. So it works all the way up the frequency range and all the way down, and this reaches down to nearly 150 hertz, which is fantastic because it's very close to the LFE crossover point. Right? So we now, just out of pure frustration, we started making our own panels. And the good thing is they're cheaper per surface area than most of the product you normally buy. And we do them in a range of colours. But the point is, what I'm trying to get across here really is you need the right acoustic treatment for the right environment for the right reason. There will be times when these are not appropriate, right? But for most of the applications we want, a smaller version of this behind that speaker on the left wall and the rear wall would deal with speaker boundary interference response really well, but it won't do boundary gain, right? Because they're not a bass trap. So that would come down to either EQ or moving the speakers. All right, so you need to understand the craft to get it right. So that, I think, is probably the world's fastest rip through video calibration, audio calibration, and a little bit on acoustic treatments. Any questions?
What are your charges?
Oh, I'm ridiculously expensive, but I'm the best there is. We can talk about that later. Any other questions? What would you like to know?
He's very good for the in and out.
Thank you very much.
That's all.
Very good.
Very good, yeah.
Oh, thank you. Oh, shucks.
I reckon Andrew can turn it like a, say, $3,000 TV into $7,000 or $8,000 just by tuning it, and I've seen the difference on it.
Oh, I appreciate
on
that.
TV and projector as well, just to get the best
for
out of
what
it.
you paid for.
Yeah.
So yeah, exactly, yeah.
I'll pay you afterwards, mate.
we had a guy who bought a Sonic TV which cost him $800.
Yep.
Yes, yeah.
And he spent how much on the calibration?
He spent quite a bit on the calibrate, more than the TV.
And ironically, that Sonic TV actually had very good RGB.
Yeah, yep.
And it actually looks like a $5,000 TV.
Yeah.
Yeah.
So, and it's not always possible, but certainly he sussed it out. Well, I'm going to spend less on the TV and get it right, than spend a lot on the TV and get it wrong. So, yeah. But look, guys, it's an interesting thing. I guess what I wanted to point out to you is that, you know, the thing that drives me, as I said earlier, is that I think people deserve to get out of their equipment what their equipment is capable of. That's what drives me. All right. I'm all about trying to get customers to get the most out of their equipment. And to me, you know, if I had my way in this world, when you design or build a home theatre and you go into a shop like this, it should be, well, we'll do a room design, and then we work out what equipment you need to get the goal that you want, to get the picture and the sound that you want, and then you need your cables and your amp, and you need calibration, because calibration is the same thing as getting what you paid for. That's the stamp and the seal at the end. And by the way, at the end you also get copies of the actual tests, so you can see what it was like before and after. And as a plug for myself, if you aren't satisfied, I give you your money back and you don't pay me anything. So it's a pretty safe bet in that sense. It's not about an ad for me tonight or for our business tonight. This is, the idea of this is for you to understand what's going on in your room. And I think the bass thing is really impressive. You know, to understand that just because you sit there, you think you're getting great sound. Right, and the same thing with your picture. So look, I don't know how long I've taken, but thank you very much for putting up with me. Thank you for coming along. And you know, if you've got any questions, please, we are Home Theatre Engineering. We have a website. Give us a call anytime. We're always happy to chat with you and answer questions whenever you want. All right?
Thank you.
You're welcome.